Hello and welcome to Laws of Logarithms Part 3. I have an exciting example sitting in front of you on the screen. It says, write as a single logarithm. So what I'm going to do, I'm going to try to combine these, and what we're going to do, first of all, notice they all have the same base. That is base 10. Otherwise, combining them wouldn't be feasible. And I'm going to do it in two steps here. Well, two or more, I guess. Let's bring in these outside numbers like this 3. Let's bring it inside. Okay, so this is actually b cubed. And we're going to do the same thing with that 5. So I'm going to bring that inside as well. Now, what that would look like is I would have the 5th root of c, and I'd be raising that to the 5th, right? By bringing this 5 in, I'm raising all of this stuff to the 5th. Now, if this is a 5th root, and I'm raising it to the 5th, they basically undo each other, and this is really just like saying log of c. So that makes it kind of nice there. Now, how do we combine these? It's best to work them from left to right, and then combine them sort of in multiple steps. So here we are subtracting, and that means I can combine these through division. Okay, so a divided by b cubed, and then I still have this plus log of c. Now this time, well, we got the same bases, and we are adding, so I can fuse them together through multiplication. So my final answer is going to look like this. A times the c, and then we have the division of b cubed. Sometimes it's helpful to put brackets around all this so that you know you're taking log of all of this stuff. All right, that's that example completed. Let's clear the screen and do another example. In this case, it says write the following. We're going to take log base b, and we've got the following stuff. A square root of a times b all over c to the 4th. And we're going to write it in terms of, now I'll explain what that means in a moment, but in terms of log of a base b, and in terms of log b base b, and in terms of log c base b. Now when we say in a question you have to write something in terms of, it means in your answer you're allowed to use only these 3 expressions and any numbers that might be appropriate. But you can't leave it as a mess of this stuff. What we're going to do is break this up, and in our answer we're allowed to use these 3 logs. So how are we going to break all this up? Well, we'll start with these 2 guys on the top are being multiplied together. So I can go log of root a plus log of b base b. And then you see how we're dividing by the c to the 4. So this would be minus log of c to the 4 base b. So that would be my first step. Now I'm going to bring some of these exponents out in front. So this guy here is like saying the square root of a, which is like a to the 1/2. So if I can write it this way, a to the 1/2, that means I can take this exponent and bring it out in front. So here's how this guy is going to look. 1/2 log of a base b. And then this one here, I'm going to leave it alone because that's just fine the way it is. You can't really break it down any better than that. And then this guy here, I'm going to bring this 4 out in front. And by by doing that, I think we have achieved our goal. We have broken it down into, there's a log A base B, a log B base B, and a log C base B, and there's some extra numbers that got thrown into the mix as well. So that means I'm done this question. All right, let's clear the screen. Next example, I'm going to try to combine the following. Combine log of 4 base 3 and 2. I'm going to try to put these things together. So how do we do it? All right, show you a little trick. You can't just make up your own rules here. So what you're forced to have to do, because this one here has a base 3, you're forced to take that 2 and write it as a log base 3 of something. So the real trick in the question is, okay, this has to be equivalent to the number 2. So I got to think, okay, a log of what, if it's base 3, is equal to 2? So if you think about it, the answer is log of 9, right? Because 3 to the 2 equals 9. So log 9 base 3 equals 2. Now I can put them together because they both have exactly the same bases, and I'm adding, so this would be like 4 times 9. So we have log of 36 base 3. So now I've combined them. Now I can't work this out, 3 to what exponent equals 36. I could give an estimate, but it didn't say to give an estimate, it just said combine. So that has been combined, and that is complete. All right, I have one last but very, very important thing to go through, and that is called the change of base formula. It's a way we can change the base of a logarithm. So I'm going to show you this very, very important formula by saying, how do I figure out something like this? Somebody comes along and says, could you figure this out? So how can I do it? I can't do it on my calculator. Most calculators have only base 10 or something called a natural logarithm, but most of them don't have base 2, so how do I do it? So here's what you do. You just say, okay, that equals something. I don't know quite what. So now I'm going to take it out of this form, this logarithmic form, and I'm going to write it in its equivalent, which is to say 2 to whatever this is, as an exponent, must equal the 5. Okay. Then I look at this and I say, hey, why don't I take logs of both sides? And I'll make it base 10. So log base 10 of 2 to the something equals log base 10 of 5. Now, the laws of logarithms allow me to bring this box out in front. So the box times log base 2 equals log base 5. And now it's easy for me to solve for the unknown box. I'm just going to divide by log base 2. So in other words, this is something I can now do on my calculator. I could go log of 5 and divide that by log 2. And I should get something that's approximately equal to 2.3219, and the list goes on. All right? What this demonstrates is something called a change of base formula. I'm just going to clear the screen and summarize the formula. It says this: if you have log of some number to a certain base, you can do this. You can go log of that number and divide it by log of your base, and you can actually choose whatever base you want. Most of the time we go with base 10. So this is an important and very handy dandy little formula, because then you could take something like, I don't know, suppose it was log of 3 base 7. It'd be really easy for me to figure out what that approximately is by just going log of 3, divide that by log of 7. And that's where I'm going to stop for now. We'll catch you later.